Okay, I think we'll go ahead and get started. We have a really exciting session for you guys today. We're going to talk about how to let your data really drive the logic in your application. So dynamic business logic based on your data. Rather than trying to do things like encoding rules, encoding your business logic, letting your data drive your logic. And how you can do that with various methodologies. We're really going to dive into AI, artificial intelligence. Essentially, how do you add human intelligence, human-like intelligence into your applications? We're going to have a guest speaker. Chris is going to present after me and talk about how Washington County is using this sort of technology to really do lead generation. Very, very powerful use case. So before we dive into things, though, I wanted to give some introductions, some definitions. So artificial intelligence, being able to add intelligence to your system or to your solution. And really, that's a superset. That's a general category of technology or methodologies. Within there, you might hear about machine learning. And that's really a set of methodologies to be able to implement AI systems. There's different types of machine learning algorithms. Some are matrix factorization. Others are other statistical approaches. What we're going to show is we're going to show some applications of deep learning under the covers. So deep learning is a specific type. Oftentimes it uses neural networks to be able to add capability and business logic into your application and learn from that data. So we're Amazon, AWS. Why are we talking about machine learning, deep learning, artificial intelligence? If you take a look, back in 1995, and if you look at the website that Amazon had in 1995, you'll notice a couple things. The first is you'll notice that there's over 1 million books already in the collection, and the second is it's already being developed various recommendation and personalization services. So Amazon as a whole has been in the machine learning and artificial intelligence for a very long time. It doesn't just start and end with recommendations, though. There's many services that we have across our company in order to do things like discovery. Rather than going into the Amazon site and going into the Kindle and going into these services and doing one thing, being able to discover other content and information that you might care about. We use heavy machine learning and deep learning within our logistics and fulfillment centers to be able to really optimize and give those folks that are working in those fulfillment centers those superpowers, right? Being able to have them do their work smarter, easier, and give them those powers of machine learning under the covers. We use the technology very heavily to enhance products. A really great example that I like, because I love movies, is Amazon streaming. What we do within there is oftentimes we're processing streaming information, and using machine learning, we're tagging what actors are in which scenes, what music is playing, and being able to have that as another facet that folks could use in order to jump to various positions in the movie, do that sort of thing. Of course, hopefully everyone's heard of Alexa and Echo. It's one of my favorite devices. I think I have an Echo device in every single room in my house. But really adding new categories of services. So rather than interacting with your service using keyboards and mouses, being able to use voice interaction in order to have an interactive experience. And there's a lot of additional features coming across Alexa and Echo, being able to add visual. So there's some new products coming out in that category. And why are we talking about all this? Really, what we're looking at doing is really making AI and machine learning something that's accessible to everyone. So all those lessons learned, all of the learning models, the thousands of employees that we have across our organization, we want to have every organization have access to those sorts of tools, those sorts of models, and really democratize the machine learning and AI field. Another really cool example, if you're ever in the area. So we have a new category of grocery store that we're also innovating on. So the Amazon Go store, really powerful. You could, somebody could walk in there, pick up what they want to purchase, and just walk out. There's no lines, there's no checkout. You just go in, you grab what you want, you walk out, and it tracks essentially what you pick off the shelf, what you put back on the shelf, And under the covers, that's very, very heavily using machine learning and deep learning. And looping this back into business rules. If you try to do something like that within your application and try to code it using rules, that would be very, very hard to do, right? How do you encode picking something off the shelf? How do you encode recognizing imagery? That sort of thing. And that's why machine learning, deep learning, artificial intelligence is very powerful. You let your data drive that logic. So why have we really seen a large pickup in this technology over the course of the last few years? The algorithms have been around for a while. There's obviously advancements in the algorithms. But really, with the cloud and with AWS, being able to store your data has really been a catalyst to be able to do this. Building things like data lakes on S3, it's very, very cost effective, easy to do, very, very powerful to store your data out into S3. And the more data you have, the better algorithms you can build and the better models you can build. These sorts of models are very data hungry. You can almost never have too much data to build some of these neural networks and deep learning algorithms. The other aspect is GPUs and acceleration and compute. Building models are very compute intensive and very, very spiky. So what you want to do, and as a customer oftentimes, is process massive amount of data in peak, being able to run an experiment and get the answer in hours, and scale up your cluster, scale it back down, and being able to iterate on your models very elastically, and the cloud gives you that. And then, of course, there's these different programming models. So there's things like MXNet, TensorFlow, Caffe, various programming models that give developers, data scientists, data engineers tooling in order to build these models. And all this drives really capability. Some examples of various capabilities are things like image understanding, image recognition, natural language processing, decision making, enhancements to recommendation engines. All this really drives business and things that would be very hard to do before these advancements. So where do some of the Amazon AI services fit in? This might, if you attended some of the other sessions, you might be familiar with some of these other categories of services. At the highest level, we have kind of AI services. And what these services really enable you to do is you don't necessarily have to be a data scientist. You don't have to have access to a massive amount of data to train your models. Remember, these models need a tremendous amount of data to be able to train very effectively, and maybe you want to do facial recognition and you don't have that amount of data to really build the models, and you want to be able to do similarity matching. So these sort of services are designed for engineers, designed for software teams to be able to integrate with, and be able to provide things like image recognition, which we're going to dive into, being able to do text-to-speech in 24 different languages, various fluctuations in text, that sort of thing. And of course, conversational bot engines. And we're going to talk about all three of these in a moment. So those are really great. They're for engineers. There's already proven models built on massive amount of data sets that you can use within your domain and within your application, and start letting those models drive a lot of your logic. There's also AI platforms. So we have our Amazon Machine Learning Service. We also have things like Managed Hadoop and Spark ecosystem as a service, where you could very easily launch a Spark cluster and run machine learning algorithms on top of it. So that's really great for data engineers, folks that want to be able to have a platform to build models, but don't necessarily want to do low-level model development, very, very nuts and bolts features. Going down the stack, though, we provide some additional services to do that. The first one to call out is the Deep Learning AMI. This Deep Learning AMI is a pre-built image within Amazon, but it has a wide number of various machine learning and deep learning libraries built into it, or bundled within that image already. There's MXNet, there's things like TensorFlow, Caffe, Torch, various libraries already in that image. So why do you care? As a team or as a data scientist, you could very easily launch a CloudFormation template, have a Jupyter notebook, and all of these libraries are already loaded on that instance, so you can start doing your deep data science work right away. You don't have to worry about how do I launch a new Ubuntu image, or how do I launch this image and load these libraries on top of that. So the takeaway here, various levels within the platform. Some are pre-built models that are doing specific functions like image recognition, conversational bots, speech to text, or text to speech. We have platform services, and then we have deep lower level services for folks that really want to dive into the library functions of building models. And of course, this is running on the AWS infrastructure, rapid integration all the time in terms of new instance types, new services at our infrastructure level. So we're going to step a little bit through some of those AI services and how you would use those within your organization. And then I'll finish kind of the stage warming act and have Chris hop on stage and talk about what Washington County has done. So the first one I want to talk to you guys about is Amazon Lex. Amazon Lex is a way of building very natural conversational bot engines. You might build a bot that talks through text. That could be like a Facebook messaging, it could be Slack, various ways to talk through text, or it could be through speech. So maybe you want to microphone enable a web page and be able to talk and ask a web page a question and have it talk back to you. In either of those forms, you're able to build very conversational engines to be able to do things like build automate service desks and help centers and various applications that need that interactive experience. Under the covers, it's the same technology that powers Alexa, so very, very proven technology, and very easy to deploy out to various forms or various targets. One of the pre-built one is Facebook messaging, Slack, various endpoints that you can deploy your bot out to. Or you can develop your own application on your mobile app or various locations on that. So this is a little bit about how it works. In this example, we're showing if there's an audio. Somebody talks to the bot, could be from a phone or could be from a microphone somewhere, saying, book me a flight in London. What happens under the covers is that actually gets mapped to what's called intents. An intent is really some sort of capability or function your bot needs to be able to provide. And under the covers, you don't necessarily have to generate every verbal model of that intent. So in this example, the person that's talking to the engine said, book me a flight. But you don't need to match the words exactly in terms of how you define interacting with that intent. You define a set of utterances, and essentially a mental model or a model of the various ways to invoke that intent gets built. And that's how the model actually ends up invoking into your intent. Within there, you also have slots. You can have n number of slots. In this example, we have 3 of them. And slots are really variables that you want to take in order to perform that function or that capability. In this example, we need the origin, the destination, and when the flight is in order to book the flight. What you'll notice is the system automatically knows how to fill in various slots. So in this phrase, we fill in the first 2 slots. And what the system's able to do is, if there's missing slots, it's able to return back prompts. In this case, when would you like to fly? And then what could happen is, the participant using the bot system could say, next Friday. That then fills the last slot, and then Lambda is leveraged in order to do what's called fulfillment. Fulfillment is really being able to execute that capability or satisfy that capability of booking the flight. So that's a little bit of a flow of what Flex looks like. We have lots of deep dives that we can go into at another time. Switching over a little bit to Poly. Poly provides lifelike speech. It's a lifelike speech service that you could use. So if you have text and you want to be able to have lifelike speech, it's able to take that text and convert it into an audio stream. A really cool example is part of Amazon is using this called Amazon Rapids. It's a new type of tablet device targeted towards kids trying to learn. And what Rapids does is it leverages Amazon Poly to be able to do various voice annotations when it's telling a story. So kids are able to read along as it's telling the story, and they're leveraging Poly in order to do various sound bites. One's a ghost, different people have different voices within the system. It uses much of the context of the sentence, so it's able to identify the difference between ways you say live versus live, Fahrenheit, cities, that sort of thing. And definitely there's a lot of great information on our AI blog about this. There's been a couple recent posts exactly on leveraging Let's and Poly to be able to add that to your applications and be able to do audio transcript, audio streams of text. So we're going to spend a little bit more deeper dive on recognition because that's specifically the service that Chris and his team is using to do the lead generation. And what recognition is it's powered by deep learning under the covers, and it's an image recognition service. And when we talk about image recognition, we really talk about multiple functions that you might want to do within that image. You could do things like identify objects in the image. Is there a weapon? Is there a person? Is there a car? Various objects in the image you can identify, and with a varying level of confidence that object shows up in that image. You can identify scenes. This is a beach. This is a landscape, that sort of scene information as well. So rather than a specific image in the object, it's identifying a broader, what is this larger scene within the image. In addition to that, there's a lot of capability when it comes to facial analysis and recognition. The first is being able to identify features of a face. Is the person smiling? You might want to do sentiment analysis. What's the gender of the person? What's the approximate age? We recently also are able to identify and release the feature to be able to identify celebrities and famous people within images. And then lastly, being able to do similarity matching. If you have a collection of faces that you care about one way or another, you're able to do facial similarity matches and find people that look the same with a certain confidence level. And Chris is going to give a demo of that here shortly. So here's a quick example. I think it's kind of a peaceful picture with the excitement during the summit, so I'd like to just kind of show a Zen picture here. So here's some of the different labels you may get with this image. And this is actually, we ran this image through and got these exact labels. So you'll notice very high confidence, there's a deer in this picture. It's about wildlife. There's woods and trees and forests. And then as you see the confidence level, as the different labels are ordered based on the confidence here. What that looks like when you're interacting with the service. So it's very easy if you have an AWS account already to launch the web console, plug in an image, and there's actually a browser interface to be able to upload a test image and see what labels it generates. But under the covers, when you're interacting with the RESTful service or through the SDKs, you get this information back. So you get what the label is, you get the confidence of that label. And the method call is called detect labels to be able to do that within the image. So talking a little bit about facial attribute recognition, here's a quick example. And these are some of the different attributes that you get out of the facial analysis or facial return within that call. So you see, is the person happy? Are they smiling? Do they have a mustache, sunglasses? Various attributes that you can very easily use, index these things in things like DynamoDB Elasticsearch, and be able to search on these attributes very, very quickly. The other thing that it gives you is other metadata. So it gives you additional metadata about where the faces show up in the image. So if you have a large image with multiple faces and you want to crop down to various faces, it gives you the bounding boxes, various landmarks for various features in the face. The recognition service never stores any of the raw image. It's all feature-based. So none of the raw images are ever stored in the service. So to show kind of what that looks like in terms of the REST API, this detect faces call here identified the various faces, what the bounding boxes are, various emotions and the confidence of those emotions, if they're wearing eyeglasses, those sorts of information. And some of the use cases that you could use this for, so oftentimes folks want to do things like take the bounding box and create those cropped images. So you can take the results, take those bounding boxes, and create pre-cropped images very easily using the service. You could also do the sentiment analysis. So this could be it could be an image, it could be various snapshots of a video stream, and identify if the various folks within that image are smiling, if they're sad, that sort of thing. You can identify demographics, being able to do pixelation, information, face editing, those sorts of use cases. So talking a little bit about some of the use cases, some of the customers that are using recognition today. This is a quick list of various domains. So we're seeing a lot of adoption in the digital asset management. So you have various media artifacts, imagery, those sorts of things, and you want to add metadata to be able to search on it. Maybe there's tons of stock photos that you want to categorize, and you don't want to do that with a human in the loop, and you want to be able to index that information. Media and entertainment, travel and hosting. We're going to talk about a public safety use case next. One really cool application is what C-SPAN has, a C-SPAN example, where it's taking the video feed and identifying which politicians are talking at any given point, and using that as metadata and cataloging that. That way, if somebody wants to know when a particular person is talking within the massive amount of video feeds that they have, they can easily jump to those locations. So very, very wide number of use cases. So from there, what we've talked about is some of the different AI services, specifically recognition, poly, and Lex. And all of those services, you'll notice those APIs are very, very high-level APIs. You could very easily integrate with that within your application. And then under the covers, it's leveraging those deep neural networks, those deep learning algorithms and models that have been developed. So very, very easy to add to your application. So from here, I want to welcome Chris to the stage here to talk a little bit about what the Washington County Sheriff's Office has been doing. Thanks.
Hi, my name is Chris Adzema, and I'm a Senior Information Systems Analyst for the Washington County Sheriff in Oregon. And I wanted to share with you guys an interesting way we're using recognition to generate leads for crimes. So let me give you a little bit of background. Let me give you a little bit of background about what we used to do before we used recognition. When we needed to identify somebody, we would send out these bulletins, which are basically PDFs that we would email to everybody who we thought might know this person in the law enforcement industry. And they would take a look at it and respond back to us if they knew that person. This obviously caused some problems because not everybody's checking their email 24/7. We have attrition of deputies and officers, so they're not there who might know this person. And so we weren't getting the response as quick as we could. Sometimes it would take days or weeks to identify somebody. Not to mention, there's in the 15 years we have data for, there's 300,000 different people who have come through the jail, and so we have a lot of people that we can't remember all of them. So I was tasked with trying to figure out how to use facial recognition to speed up this process. And right about that same time, AWS announced recognition. So we thought it was an excellent example of how we could attempt to use facial recognition. So we took all 300,000 of those mugshots that we had, uploaded them into S3, used recognition to index them, and now we can search them to find who we're looking for. And this has taken it from from days or weeks trying to recognize these people to minutes and seconds. So I wanted to share a little bit of the code. We already saw what the responses would look like, but this is how easy it was for me to set up once I had all the images in S3. 3 easy steps got me all of my images indexed in recognition. I just had to simply create the objects, the recognition and the S3 objects, list all of the object in the bucket in S3, and then loop through that, calling the index faces API. And this is using the PHP SDK, but it's as easy in any other language too. Now, next, again, really simple to search using the SDK. Simply create the objects again, get the binary data from the file, and send it off to the API for search faces by image. It will return all of the results based on the thresholds that you give it. In this case, the only threshold I'm saying is only give me 5 faces, so it'll give me the best 5 matches. You can also select the similarity threshold if you needed to. So after all that, I'd like to share a real-world example here. All right, this is my favorite example, and this actually happened the day I turned on the service. This gentleman here walked into a big box hardware store, put a whole lot of products in his cart, walked to the self-checkout and started scanning them. Once he was done scanning them, he put them back in the cart and walked out without paying. So luckily, the self-checkout has a camera, and we got this image. So I ran it through recognition, and I got 4 results. Now, I was able to take a look at these 4 results and notice one of them looked very similar to the person in the picture. I even noticed a little thing on his lip there that looked very similar to the suspect. So I gave his information to the detective running the case and the name. And the detective went to Facebook with that name and looked for a public profile picture. And we found this as his public profile picture. And it looks very similar as well. From the laughs, I think you guys have taken my punchline, unfortunately. Notice he's wearing the same hoodie. With just this information, we were able to get a warrant for his arrest and apprehend him. This happened within 30 minutes of us getting this picture from the hardware store, whereas prior to this, it could have taken weeks. So we were able to apprehend him with the products that he stole still in his possession, as opposed to if it had taken a week, he would have gotten rid of them already. So a second real-world example I wanted to share is actually one that I want to share because it shows how the human element can actually mess us up. Now, this is a picture of somebody who is currently a fugitive from Washington County Jail. He was convicted and he never showed up to go to jail. It's not that he escaped or anything. So I went to his Facebook page because I wanted to see if he had been posting anything since he'd been convicted but failed to appear, to see if maybe we could get some geotagging or something like that. Unfortunately, no, because he's at least a little smarter than to do that. But when I saw his profile picture, it didn't look like the person who I thought I was looking for. When you look at his mugshot, there are definite differences, to me at least, that I wouldn't have picked these 2 people to be the same person. But when I ran it through recognition, it showed that he had a similarity, these 2 pictures had a similarity of 95%. So basically that shows that even though a human would have looked at these 2 and said, oh, they're not the same person, the recognition was able to tell me that with a high certainty it actually was, and therefore it's easier for recognition to search all of our pictures and not just rely on the humans. All right, so I wanted to do a quick demo for you guys. Now, forgive the clunkiness of the UI. This is just too simple to show you what's going on. But something that we've just started doing is taking actually sketches and running it through recognition. And we are able to get matches based on these sketches. Now remember, these aren't, I'm not going out and saying that is indeed that person, but it's at least a lead for our detectives to go and look at. And it's something we couldn't have done before. Obviously, when we have a sketch, we don't even have a picture of the person. But with this, at least now I have at least these 2 people to say, hey, maybe you should go check these guys out. All right. So now that you've seen that, I wanted to talk a little bit about the benefits. Obviously, I've shown you how quickly we can identify people, but it has brought it down from, like I said, weeks to seconds. And what we just showed, that's recognition. Yeah. We've been able to get this identification down rather quickly to the point where we're relying on it more than we're relying on the bulletins that we sent out previously. Another great benefit to this was actually that prior to January, my department, the entire sheriff's office had never used any AWS product before. However, as soon as we learned about this, we picked it up and are now using it to this extent with less than a month of actually starting. To the point now it's about 6 months later, but it's in full use to identify these people. And thus learning AWS has opened up all of the other AWS products that are going to be benefiting us in the future. And then obviously the biggest benefit is, like I've shown you, we've actually arrested people based solely on information. Well, I shouldn't say that. We have arrested people based on leads generated from recognition when there were no leads prior to that, which has been obviously beneficial to public safety by getting criminals off the streets. And then the next steps that we're going to be taking are broadening this out so that it's not just me and my team running the facial recognition, but I want to give the app to all of our deputies. We've actually created a mobile app for iPhone that they're going to be able to take a picture and scan it right there on their phone. This will actually have benefits beyond just identifying people. Right now, if you have a license and you want to run that license, you have to type it into a computer and it'll chug along finding that license, the name for that person and whether or not they'd ever been in our jail. Now you can just take a picture of that license and it'll tell you within seconds. And then obviously having it to identify people and like that will be great. We also are working to expand our collection so that it's not just using Washington County jail mugshots. We want to expand it to other counties in our area so that not only will we have the information from those people, but those counties can also use the system to identify people in their counties. And the broader it gets, the more results we're going to get and the better we're going to have finding people. And then the final step that we're going to take actually has nothing to do with catching criminals, but we have a product, or I shouldn't say a product, it's a service that we provide called Help Me Home, which is geared towards elders and developmentally challenged children who have a propensity to get lost or wander away from home. This service is something you register for at the sheriff's office, and when you register that, we get information from you like who to contact if we find this person, how to handle them, like if they don't like being touched or approached, how to deal with that. The biggest problem right now is that if you come across somebody who you feel would be in the Help Me Home database, you have to search using demographics like height, weight, eye color, and things like that. Whereas we would be able to just take their picture and they would return and say, that's this person and this is how you handle them and this is who to contact. So that's the next step we're going to take. And hopefully that'll help keep those people safe and get them home quicker. All right, that's the example, and I'll be up here later to answer any questions you have.
So definitely want to thank you. And so we'll stick around up here to answer questions. One other thing I should just quickly mention, one recent development is we just released recognition in GovCloud as well. So it is in the GovCloud region for folks that in the public sector that are running there. So we'll stick around up here, and thank you again.